Hello there, Wildcats. Today we are going to discuss about arithmetic sequence, and we are going to connect that with linear function. Okay, so let's go and jump into our first example. Is the ordered list 26, 39, 52, 65, 78 an arithmetic sequence? First is we have to define what is a sequence. A sequence is an ordered list of number that often form a pattern. Each number is a term of the sequence. Now, in arithmetic sequence, the difference between any two consecutive terms, meaning they are right after each other, is constant, called the common difference. So we'll be checking if these given numbers are have a common difference, so that we'll consider that as an arithmetic sequence. So if I'm going to subtract 39 minus 26, so from 39 minus 26, so that will give us 13. And same with 52 minus 39, which is also 13. You have 65 and 52. You subtract that, will give you also 13. And the last one, 78 and 65, will give you 13. So meaning, to get the next number, you have to add 13. Now, to check if the sequence is an arithmetic sequence, then we have to get the common difference. So the common difference is 13. So this is an arithmetic sequence. It's a yes. It's an arithmetic sequence. Now, how are the sequences related to the function? So you can think of a sequence as a function where the domain, okay, the domain, again, just a reminder, domain is those are the values of x's, is the natural number, and the range, the values of y, which is your output, is the term of the sequence. So in our letter A example, 26, 39, 52, and 65, 78. So let n is the term number in the sequence. Okay, so that is the number in the sequence, and then let A times n, which is this now will be the value of the nth term of the sequence. So the first term, okay, which is that's the first term, this is the second term, this is the third term, you have the fourth term, and then we have the fifth term. Okay, so A1, meaning A1, that's the first term, which is equivalent to 26. A2 is equal to 39. So if you go forth, you have A3 that is equal to 52. A4 is 65. A5 is 78. So the first term is 26, the second term is 39, the third term, the fourth term, and so on and so forth. Okay. Now, how do you represent the sequence using a subscript notation? Subscript notation, it's in this manner, we have A sub n. So the subscript is the n. Subscript notation is commonly used to describe the sequence. So I want to check this one. I'll erase that. So that must be A sub 2 is equal to 39. The number 2 as a subscript, it describes what term is the number. So 39 is the second term in the sequence, right? Next example, let's jump in. A sequence is defined recursively, okay, below. So when we say recursive function or recursively, in mathematics, means to repeat a process over and over again. Okay, so just like what we did a while ago. So the difference is 13. So you have to repeat the process until you get, this is succeeding numbers. Using the output of each steps as the next input. A recursive formula relates each term of the sequence to the previous term. it is composed of the initial value and a rule for generating the sequence. Okay, so the definition of recursive function, it's below this video. So if you go to your canvas, you have the definition of recursive function, and then how recursive function formula is written. Okay, just like what I said a while ago, a sub 1, that's the first term, a sub 2, the second term. Okay, now we're going to relate your sequence to the function. So what are the problem here is, what is the fifth term of the sequence? So based on the definition of recursive function, we need the term prior to the fifth term, which is the fourth term. However, we don't have fourth term, so we need the third term. So we have to solve the second term, third term, fourth term, and then so we can get the fifth term. Okay, the question here is, what is our first term? So we have 5 terms here. We have first term, that's 1, the second term, the third term, the fourth term, and until we get to the fifth term, that is our problem now. And the given first term, which is f1, which is 2. That is our first term. First term has a value of 2. Now, using the recursive function, which is fn is equal to -3, the function of n minus 1. Your n minus 1 here, meaning this is the previous term. Okay, so we need the previous term to do that. Okay, because we already have your f1, so we have to go with f2. So f2 is equal now to, using this one, -3 f, what is our n? The n is 2. Okay, n is 2, so that's 2 minus 1. That will give us -3. F of 2 minus 1 is 1. Now, take note. One of the common mistakes that students are doing is that they multiply -3 and 1. No. Your f1, you have the value of f1 already, which is this one. f1, okay, that is f1. You just plug that in. The value is 2. So you have -3, the value of f1, which is 2. Therefore, your f2 is -3 times 2, it's -6. So the second term, which is f2, is -6. All right, so you have just like what I mentioned a while ago, recursive function is you are repeating the process. So you are going to repeat this. So you have f3 is equal to -3 f of your n is 3 minus 1. So you have -3 f 3 minus 1, which is 2. And we said that f2 is -6. So you have -3 f2, not -3 times 2, but the f2, which is -6. I am reiterating that. It's because that is the common mistake that the students are doing. So -3 times f2, which is f2's value is -6. That is the previous term before f3. Therefore, your f3 is equal to positive 18. So f3 is positive 18. Now you have f4. So f of 4 is equal to -3. And then f4 minus 1, which is the previous term. So -3 times -3 f of 3. That is f of 3. F of 3 is 18. Therefore, your f4 is equal to -3 times 18. That is -54. So we have negative 54 in this one. And then the last one will be f5. Okay, so this is now the function. So you have f5. This is the last one. f5 will be negative 3 times, we have f5 minus 1, which is the previous term, which is the 4. So f positive 4. Again, do not multiply negative 3 and 4, okay? So we have negative 3 times the f of 4, which is negative 54. Therefore, your f5 will be equivalent to negative 162. f5 is negative 1, sorry about that, negative 1 over 1, negative 162, sorry, negative 1 over 62. Therefore, our sequence here, the fifth term is negative 62, so I'm going to write this one in a sequence. So we have 2, negative 6, positive 18, then negative 54, and then we have negative 162. So that is how you find the missing term on the sequence. So you need to have the previous term, okay, to solve the next term. And again, do not multiply, most especially if they are given like this one. So negative 3, f2, do not multiply 2 and negative 3. All right, next example that we have here. So we are going to solve a word problem using recursive function. Right, so in this word problem, the cost of the renting a bicycle is given in the table. So this is the table. So how can you represent the rental cost using an explicit formula? I want to underline this one because, again, the definition of explicit formula is below this video. So your explicit formula expresses the nth term of the sequence in terms of n. The explicit formula for an arithmetic sequence is an. Okay, so explicit formula is expressed as a sub n, the subscript n, is equal to the first term, a1, that's the first term, and then you add the previous term, which is n minus 1, and then you have to multiply the common difference. I'll repeat. Your explicit formula is expressed as the an is equal to the first term plus the common difference of the sequence times the previous term, which is n minus 1. All right, so first is we have to identify your first term, which is a1. Your a1 is equal to 26. Okay, which is this one. And then let's take a look at the common difference of this. So the common difference, I think it's 38 minus 26, that is 12, right? Let's see. 50 minus 38, it's still 12. And then 62, 50, it's 12. So our D in this example will be 12. Now, we are going to rewrite this one as an explicit formula. So an is equal to the a1, which is 26, plus the previous term, which is n minus 1. That is n minus 1. And then the common difference is d, which is 12. Okay, and then you have to simplify this, so it will give you 26 plus you distribute 12, distributive property, distribute. Okay, so it will give us 26 plus 12n minus 12. And then from there, you simplify. You have now an, that is 26 minus 12 will give us 14, and then plus 12n. So the explicit formula is a sub n is equal to 14 plus 12n, gives the rental cost for n days. So this gives the rental cost for the number of days. Again, your independent variable here is the number of days. So every time you add the number of days that you will be renting the bicycle, it will add the to the cost also. It will increase the cost. All right. Letter B. What is the cost of renting the bicycle for 10 days? So you are looking for, okay, you are looking for the 10th day. Okay, and we know that n, it's the number of days. So the only thing that you have to do is a, and then we have the 10th is equal to 14 plus 12 times 10, because your n is 10. So by just calculating that, a10 is equal now to $134. So you can now say that it cost $134. Sorry about that. 134. I have to write that properly. 134 for 10 days. That's 10. There you go. All right. So we're now going to relate recursive function into linear function. As you can see on the graph here below, when I graph it, so the first day you have 26, it's increasing and it's a straight line. Okay, the formula a sub n is equal to 14 plus 12n shows that the cost is a function of the number of days the bicycle is rented. You can write this as a linear function. You can write as f of x, okay, is equal now to 4. You can now write this one as 12x plus 14, or you can write as y is equal to 12x plus 14. This is in slope intercept form, that your 12, okay, 12, this 12 here, okay, is the rate of change. Okay, I'm using the word rate of change, or rate of change, or the slope. So it changes because the common difference, we said it's 12. So your the rental cost will add 12 every single day. So if you have the 5th day, you have to add 12 to 62. All right. Next. Now in our next example, we have to write an explicit formula from a recursive formula. And the second example is we are going to write a recursive formula from an explicit formula. So it's in vice versa. So from explicit to recursive, recursive to explicit. So let's start with the first one. Identify the recursive formula of the height above the ground of the nth step of the stair shows a sub n is equal to a n minus 1 plus 4 with a1, which is 7, which is the first step. What is the explicit formula? What explicit formula finds the height above the ground of the nth step? Okay, so a1 is equal to 7, and then we have a sub n is equal to a n minus 1 plus 4. So take note, the 4 here, this is the common difference. So I'm looking at what I'm writing. There you go. So that's the common difference. So write an explicit formula. So when we write an explicit formula here, we have an is equal to a sub 1 plus the previous term, n minus 1, and then the common difference, which is 4. So I have an, the first number in the sequence will be 7 for the first term, plus n minus 1, and then the common difference, which is 4. So we have to substitute 7 for a1 and 4 for your common difference. Thus, the explicit formula will you can use is this one: a sub n is equal to 7 plus the quantity n minus 1 times 4 can be used to find the height above the ground of the nth step. So if you want to simplify, you can simplify it, but I'll stay with this one. All right. And our last example, we have to write a recursive formula from an explicit formula. So first is you have to identify the common difference. So step 1, common difference. So identify the common difference. So the common difference is a n is equal to 1 plus 1/2 n. So d, the common difference is 1/2. Okay, so step 2 is we have to find the first term of the sequence. So what will be the first term? When to find the first term, what we are going to do is we let n to be the first term, we let n to be 1. So you just plug that in. So n is 1 is equal to 1 plus 1/2 n. So a1. So I just have to plug that in. So there must be 1 there. So your a1 will be 3/2. So this is your first term. Now we have the common difference. We have the first term. You can now write the recursive formula. So the recursive formula now is an is equal now to the first term, which is write the recursive formula. So an will be an a sub n minus 1 plus d, which is the common difference. So we substitute a1 for d. So an is equal now to a n minus 1 plus 1/2, right? 1/2. Okay, so this is now your recursive formula. But always remember that the recursive formula, you need your a1 which is equivalent to 3/2. So those are the example of recursive formula and arithmetic sequence. I hope you learned something from this video. If you have any question, just let me know. Just hit me an email, and please join us in our live session every day. Thank you, and bye-bye.